Hello and welcome back. Here we are on Notes 1-3, Ratios with Fractions. Finally, you've made it to your video that you'll be viewing on your own. Go ahead, give the launch a shot, pause the video. When we come back, we'll talk about it. So you could be pretty wordy with this, or you could be minimal with the wording here. The answers that I did have were 4 to 2, 6 to 3, 1 to 1/2. My explanation was that plate 1 has a ratio of 4 to 2, and plate 2 has a ratio of 6 to 3. So plates 1 and 2 have twice as many apples as pears. So if we're going to keep that going, to have the same ratio of apples to pears, plate 3 should have half a pear because 1 is twice as much as 1/2. I'm sure that some of you weren't quite as lengthy as I was with my response, but we want to show that we are being specific here. We're going to jump right into a key concept that says how to simplify ratios where one term is a fraction. It goes on to say that you can have a ratio where one term is a fraction. That's called a complex fraction. Add that right in here. We will talk about that more, but that's called a complex fraction. Fraction within a fraction. Simplify these ratios by finding an equivalent ratio where both terms are whole numbers. So we're trying to take our complex fraction and make the numerator and denominator just a whole number and a whole number. So to do this, it says to multiply each term of the ratio by the denominator of the fraction. Then write the ratio in simplest form. Now it says by the denominator of the fraction. That doesn't mean looking at 4/5 divided by 6, that 6 is the denominator. They're saying look at the denominator of the denominator in your fraction, which I know is a little bit confusing. What they did not do a great job with the diagram here is showing you where the main fraction bar is. So I'm just going to exaggerate that this is really 4/5 divided by 6. So when they are multiplying by 5, they're saying that's the denominator in the numerator. We then get 4/30ths after you multiply, because I'm just going to show you on the side, when you multiply 4/5 times 5, you're really multiplying times 5 divided by 1, and the 5's cross cancel to just leave you with the 4 that they have here. And 6 times 5 then gives you 30. We're now going to write that fraction in lesser terms by dividing and getting 2/15. So the statement goes on to say the ratio 4/5 divided by 6, written in simplest form, is 2/15. Now, if you're not quite sure about that, we are going to do a couple examples together, so you'll see me walk through this. Example number 1 on the next page says that your neighbor commutes 12 miles to work. You commute 9/10 miles to school. They want us to write the ratio of your neighbor's commute to our commute as a fraction in simplest form. I like to, again, mark up my question as much as I can. So the neighbor's commute is 12 miles. Main fraction bar, your commute is 9/10 miles. Because we both have the numerator and denominator in miles, I can go ahead and cancel out the units there. And then I'm going to multiply by the 10 that is in the denominator here. So what I'm really doing is I'm multiplying 10 on the numerator, 10 on the denominator. This 10 divided by 10 is equivalent to 1. It doesn't change the value technically. I'm left with 12 times 10 to give me 120. And then on the bottom, really I'm putting 10 over 1 here. Those 10's cancel out, which just leaves me with 9 times 1, which just is 9. That is not in simplest form. I can divide both of these numbers by 3. I know that I can divide them both by 3 because 120, the divisibility rule for 3 was if I add up the digits and the sum is divisible by 3, the whole number is divisible by 3. So 1 plus 2 is 3, plus 0 is still 3, so I know I'm divisible by 3, and I will get 40/3. Leave your answer as an improper fraction. This goes against what we normally do in 7th grade, but because they want it to be a ratio as our final answer, it does have to be a comparison of two numbers, so we're going to go ahead and just leave it as a fraction. Part B is very similar to Part A. They're saying to write the ratio of our commute to your neighbor's commute now. So we're using the same numbers from the previous question. This time I will put 9/10 in the numerator. I'm really exaggerating that main fraction bar there and putting that over 12. Again, I can cross out my miles, and the denominator 10 in the numerator needs to be canceled out. So I'm going to multiply the top by 10 and the denominator by 10. This is really 10 divided by 1, which allows me to cancel out the 10 and the 10. So now I have 9 in the numerator, and then 12 times 10 to give me 120. Again, I can reduce both the numerator and denominator by 3 to give me 3/40. Part C is asking, how are the ratios from parts A and B then related? Well, 4/43 and 3/40, they are reciprocals. Go on to number 2, give that one a try, pause the video. Here's the answer that I got. If I'm comparing running to weightlifting, I need the running in the numerator, the weightlifting in the denominator. 3/4 of an hour divided by 2 hours. I'm multiplying by the 4, which is the denominator, to end up with an answer of 3/8. Now we go on to quite a bit of me talking because we're talking about the key concept here. There's quite a bit here. If after this lesson you still don't quite feel 100% with this, please ask me for help. One of the concepts we have that says that to simplify ratios where both terms are fractions. First, we need to discuss what the least common multiple is. You should recall that the least common multiple of 2 or more numbers is the smallest number that both numbers multiply into. So we're actually looking for a bigger number. That word least is very deceiving. We're really focusing on the word multiple, meaning multiplication. So if I wanted to find the LCM of 6 and 8, I have now listed here the multiples of 6 are 6, 12, 18, 24, 30, and so on. The multiples of 8 are 8, 16, 24, 32, and 40. The smallest number that is common to both lists is 24. Therefore, the least common multiple of 6 and 8 is 24. That's just a refresher for you. On the next page, we continue to talk about how to simplify ratios where both terms are fractions. In the previous examples we did, only the numerator had a fraction, or the denominator had a fraction. Now, we're going to have fractions within fractions. The directions are saying simplify these ratios by finding an equivalent ratio where both terms are whole numbers. To do this, we're going to multiply each term of the ratio by the least common multiple of the denominators of the fractions. Then we're going to write it in simplest form. So the least common denominators of the fractions, in this case, we're going to be comparing the 4 and the 7. So we're walking you through here. The solution says find the least common denominator, or least common multiple, of 4 and 7. It's similar to finding the least common denominator. Since the LCM of 4 and 7 is 28, we are actually going to multiply each term of the ratio by 28. I'm just going to write on this a little bit more to make it a little bit more friendly for us. When we say we're multiplying the numerator by 28 and the denominator by 28, you're doing 3/4 times 28 over 1, really, and then 6/7 times 28 over 1. Because we're using the least common multiple on purpose, it's allowing us to cross-cancel. It means we will definitely get rid of the 4 and the 7. 28 divided by 4 is 7, so that becomes a 7 up here. 28 divided by 7 is 4. That becomes a 4 up there. So that would leave us with 21/24. At first it seems kind of complicated, but I just wanted to kind of break it down so that you saw that work a little bit more. Step 2 goes on to say 3/4 times 28 equals 21, which I'm showing you how we got that. And 6/7 times 28 equals 24. So now that we have 21/24, second here. Now we have 21/24, we need to reduce that fraction by dividing the numerator and denominator by 3. And all that beautiful work brings us down to that the ratio in simplest form is actually 7/8. Our work is not going to take up nearly as much work as this problem just did. I'm going to show you with example number 3, which is squeezed into the bottom of your page there. They're asking us to write the ratio 3/4 gallon divided by 9/10 gallons in simplest form. Since again it says the word ratio, we really want to focus on the fact that we want to have the same unit, so it cancels out. Because I have the same units here, I can go ahead and cross off the gallons, and I'm just going to rewrite 3/4, again exaggerate my division bar, divided by 9/10. I am going to be really focusing on the denominators, which in this case are the 4 and the 10. The least common multiple between 4 and 10 is 20. If you wanted to multiply them by 40, that's fine. Your math would just be using larger numbers. So I'm just going to multiply it by 20 instead. So I multiply the numerator by 20 and the denominator by 20. That now allows me to cross cancel. 20 divided by 4 is 5. 20 divided by 10 is 2. Multiply what you're left with. I'm multiplying the 3 times 5 now, which will give me 15. And then I'm multiplying the 9 times 2, which will give me 18. I see that both of these numbers are divisible by 3. 15 divided by 3 will give me 5. 18 divided by 3 will give me 6. And so my final answer is 5/6. We'll try that again together, just so to make sure that we're on the right path. If at any time you guys need to pause the video or rewind to capture anything, go back and check it again. That's fine. So they're asking us to determine whether each statement is true or false. For A, they have feet squared and feet squared. So I'm going to right off the bat cancel those out. Again, it says ratio, so you have to have no units in your final answer. I'm going to rewrite 2/3, all divided by 1/5. I'm looking at the 3 and the 5, and I'm trying to decide what is the least common multiple of 3 and 5. And I get 15. That allows me again, 15 divided by 3 gives me, not 3, 15 divided by 3 gives me 5. 15 divided by 5 gives me 3. I'm left with 2 times 5 is 10, and 1 times 3 is 3, and I get 10/3. Again, remember, we're leaving our answers as an improper fraction. That is a true statement. Both of them are equivalent to 10/3. You guys are going to try B and C on your own. Go ahead, pause the video, and then when you return, surprise, the answers will be there. Okay. Here is my work for B. Sorry about that. I said that it was true. Again, I canceled out my units. I multiplied the numerator and denominators by 35. I cross-canceled my units. Got 7 and then 5. Multiply, make sure I reduce, and I do get that it's equivalent to 14/15. For C, I got false this time. Even though the numbers are similar, they're in the incorrect order to provide to be a ratio. I canceled out my units. I am multiplying by the LCM of 9. I think this is the first time that this has happened where the LCM is also one of the denominators, and that's perfectly okay to use the least common multiple. Go through, divide it out, I get 3/2, which is not true. Okay, now here comes the doozy. Number 5 looks innocent enough. It states that a professional football field is 53 1/3 yards wide. Find the ratio of the width of the actual field to the width of the field in the poster as a fraction in simplest form. The width of the field to the width of the poster. The 53 1/3, that's the actual, and the poster, the drawing, is obviously the poster. They want us to write this as a ratio, and if you notice, they gave us yards and feet. So in order to actually write this as a ratio, we have to do some conversions first. You can either convert yards to feet or feet to yards. I'm looking at this problem, and since the 53 1/3 yards, I know that I would probably have to divide. It's going to end up being a little bit more complicated. I'm going to change the feet to yards. So I'm going to first convert feet to yards. Again, if you went yards to feet, your answer would be different than mine to start, but at the end, we would simplify down to the same ratio. I do need to change 1½ to an improper fraction. I'm sorry, I'm actually going to write 1½ feet. I don't want to start skimping now. And that's going to give me 3/2 feet. So we're going to go through our conversions using our conversion factors. So we have 3/2 feet. Be very careful. That whole thing is over 1. It's not 3 and then 2 down below here. We always multiply when we convert. We put our new unit in the numerator, so our new unit is yards, and we put 3 feet in the denominator. I'm going to cross cancel my units of feet. I am left with 3/2 all divided by 3 and the unit of yards, but I have a fraction within a fraction. I need to multiply by the 2 to both the numerator and denominator to keep this ratio equivalent. Cross cancel my 2's. I'm now left with 3/6 of a yard, which is the same thing as 1/2 of a yard. So all I've done is change the poster over here to 1/2 of a yard. Now I need to do the ratio part. So I'm comparing the actual to the poster. The actual was 53 1/3 yards. The poster we converted to 1/2 yards. I can cancel out my yards denominator. The 53 1/3 though, I need to change that to an improper fraction. So now I have 1/60 3rds. Remember, we go 3 times 5, 53 times 3, which is 159, plus 1 to give us 160. Main fraction bar, make sure you can tell where that is. Bring the 1/2 over. Now I'm going to multiply by the LCM of 3 and 2, which is 6. I do my cross canceling. 6 divided by 3 is 2. 6 divided by 2 is 3. 160 times 2 will give me 320. 1 times 3 is 3. I check to see if I can reduce this. 3 plus 2 is 5. So I know that that number will not be divisible by 3. Again, we leave our answer as an improper fraction, and we will get 320 thirds. You're going to go on to number 6 on your own. Okay. This one, when I looked at it, since I knew the last question we had to change our mixed numbers to improper fractions, I just went ahead and changed the mixed numbers to improper fractions within the question. We are talking about inches and feet this time, so I converted between inches and feet. I said that at the end I get 25/48 feet. I couldn't work this one out to not have a fraction, so I end up with a complex fraction, which is no biggie. We've now learned how to deal with those. So you now really don't have to worry about which unit you need to convert to. Just as long as you use the correct conversion factor, doesn't matter if you decide to do inches to feet or feet to inches. I got 25/48. That is representing the information for the model vote, so I need to make sure I'm clear with that all of this was for the model. In words, I'm comparing model to the actual. Set up 25 48ths, all divided by 25 halves. My least common multiple is 48. Go through and simplify, and I get 1/24. If you have any questions about this concept, please ask me tomorrow. We'll be working on the homework in class, and you'll have time to ask me questions then. See you tomorrow. Bye-bye.